Hey, this is Mrs. Thompson. We are looking at some rates of change. This is lesson 5.1 for algebra. The standard that we are looking at is FIFA 6, which is dealing with all of our functions. One of the essential things that I need for you to be able to understand, and if you're also looking, you'd be in your textbook in lesson 5.1, is that you can use ratios to show a relationship between changing quantities, such as what's called the vertical and horizontal change. This is a special name. We call this our rate of change. Now, as you're looking, you should be in your notes. If you look in your notes, you would be on page 2, or actually page 1. Rate of change shows the relationship between two changing quantities when one quantity depends on the other. The following always is true. The rate of change, if you fill this in your notes, is going to be the change in the dependent variable divided by the change in our independent variable. Now, if you think about when we talked about our dependent variable, that's going to be the change in y. This triangle just means change divided by the change in x. I also put online for you that you can go to the digital path, go to 5.1 and watch the virtual nerd video. If this would help you out also, it talks about the formula for slope. Finding the rate of change using a table. Well, if we're looking at this table, it says at the right it shows the distances marched over time. The rate of change in each row is next to 260 feet per minute. Do you get the same rate of change per minute if you use non-consecutive rows in the table? It says to explain. So what we want to take a look at, and you are going to pause the video, is that you want to find the rate of change in the distance divided by rate of change in the time. Remember, if we think of the last chapter, time is usually our x, distance is our y. Independent variable, dependent variable. So if we are looking at this, we want to find three rates of change is what I asked you to find. So we know this first rate of change is definitely 260. It asks us to find two other rates of change, and the change here is 1. So if we're finding the change in distance, we might be looking at going in 3 minutes for 780 feet, and we might look at 4 feet with 1,040. I'd also have you do one more, is that if we go from 1 minute, where they have marched 260, and then you will have gone to 4 minutes, 1,040. How do we find the rate of change? We are going to subtract change, remember. Anytime you find change in y, that really means subtract your y coordinates. Change in x simply means subtract your x coordinates. So right now at this point, remember, we are looking at our x and y coordinates, x, y in each one. So our rate of change is actually going to be equal to, we are going to take 1,040 minus 780 divided by 4 minus 3. If we do our subtraction, 4 minus 3 gives us 1. 1,080 minus 780 gives us 260. That is the same rate of change. What about if we look at this rate of change? We are going to take our rate of change, and again, this time as we find our rate of change, we are going to be looking at taking 1,040, subtracting 260. We are dividing 4 minus 1, the change in our y coordinates, or our time. This comes out to be 3. So if you were finding this rate of change and you did the subtraction, 1,040 minus 260 gives us 780. You should have this written in your notes. We're going to do the division. 780 divided by 3 gives us 260. So we're getting the same rate of change for each one. So it says graphs of ordered pairs that compare time and distance in this problem lie on a line, as shown at the right. The relationship between time and distance is linear. So we think about our linear and nonlinear from last chapter. It says when the data is linear, the rate of change is constant, and that name has a special name. You're going to enter this into your notes on the first page. It's called slope. says, notice that the rate of change in problem 1 is a ratio of the vertical change or the rise to the horizontal change or the run between any 2 points on the line. This has a special name called our slope. This is some of the information that you would put down on that very first page of your notes if you want to pause and add this in. So what is a slope of a line? Slope of the line is equal to the rise over the run. If you look at any line, you might want to try and pick the points that are at this point. You notice -2, 1, and then 1. -2, -1, and 1, 1. How far do we have to go up? What is our rise? Our rise in this point is actually going to be, we rose up 2 units. Since we went up, we think of that as positive. And when we go to the right, we think of that as also being positive, and our slope of this line is going to be 2/3. Example, as you were looking at that on your page. Again, in this one, as you look at the slope, it says the slope is if we go down 4 units, and if we think of going down, we might think of that as a -4. That is our rise, and in this case, we can think of it as rise or fall. And to the run, and if you're going to the right, we would think of that as +5. So our slope is a -4/5 if we are looking at that line. Now, sometimes it's easy to look at a graph, but if we don't have a graph, we actually want to use this equation that we are looking at. It says any 2 points on a line, you can find its slope. The subscripts are distinguishing the 2 points, so we think of this as x1 and y1, where the coordinates of A and x2 and y2, notice here, are coordinates of B. And here is our slope formula. Slope always equals, I always want you to get in the habit of putting down rise over run, y2 minus y1 over x2 minus x1, and it's always important that this x2 minus x1 is not equal to 0. Remember, division by 0 is undefined. Division by 0 is always undefined. Now, if you are looking at this graph, what we want to take a look at is, in this equation, could you switch it around? Could it be y1 minus y2? You can, as long as you put x1 minus x2. One of the things I want you to notice is that anytime you're looking at these, when you look at your lines, this is your first coordinate point. Those two have to be above and below each other. And if x2 and y2 is your second point, they have to be above and below. The other thing that is key is it is always the difference. You are subtracting. That is change. So as you're putting these in your notes and you look at those. So let's think of finding the slope as we are looking at point -1, 0, and 3, -2. First thing I'm going to have you do is start by writing down the slope formula. So slope is equal to, again, you're going to be filling this in your notes as you're writing this down, y2 minus y1 over x2 minus x1. And again, if you just want to put y minus y over x minus x, that's fine. As we substitute in, they're telling us this is our x1, y1, and our x2, y2. So when we start substituting in, we want to put down, and the most common mistake is people want to put the x's first. We want to put our y's, -2 minus, in this case, 0, divided by, what is our x2 point? Our x2 was 3. 3 minus, and in this case, we got to be careful, it's -1. Now, again, if you want to show this in one line, you could. In this line, we're looking at 2 minus 0, which gives us 2. 3 minus a -1. Remember, subtraction changes to add the opposite. 2/4, and we can simplify that, and our final answer is a +1/2. If you wanted to check it, you could do a quick rough sketch. Here's our y and x axis. -1, 0 is a point here. 3, -2 means over 3 and down 2. If we are looking at that, we should have had a -2, right? -1/2. We are looking at our line. We went down 2 points. Down 2 over 4. -2, +4, -1/2 slope. We also have some very special lines, and if you look at, now you should be on page 3, if we are looking, finding slopes of vertical lines. As you are finishing this off, slopes of our vertical lines, we want to put down our formula. So first thing we're going to write down is our formula. Y minus y over x minus x. If we look at our y2's first, we might have 2 minus 2 divided by our x2, if we are looking at that, is going to be 2 minus a negative 3. Now we want to get our slope as we're looking at that. 2 minus 2 gives us 0. 2 minus a negative 3 gives us 5. Anytime we divide 0 by a number, we get 0. And if we have a horizontal line, the slope is always equal to 0. One of the things that's helped students in the past is if they can think of this phrase, H, O, and then we are looking at Y, HOI. The H, what does it stand for? Horizontal line. What does the O stand for? 0. That means our slope of all horizontal lines are always 0. What about the Y? Our equation for our line, if it's horizontal, is always y equals any number. So as we start graphing, you're going to notice some of these, if we're looking at our points, how do they look and how can we relate them to each other? If we look at this second example, again, first thing we want to do is write our slope formula. Y, and if you want to put y2 minus y1 instead of just y minus y, x2 minus x1. And what happens if we have a vertical line? Do we know it's a function or not? We should know from last chapter it is not. As we look at this, we now want to take 1 minus a negative 2. In our denominator, our x2 is negative 2 minus a negative 2. So we have 1 plus 2 divided by negative 2 plus 2 is 0. 3 divided by 0 is undefined. And our slope of a vertical line is always going to be undefined. Now again, another phrase that can help us if you write down is V, and then we're going to put U and X. I'm sure you can guess at this point the V is vertical. The U is because our slope is, yes, you guessed it, undefined. And the equation for a line, that's what our X stands for. Our equation is always going to be X equals any number. And we will always have a vertical line. As you take a look at this example that's on the bottom of your page 3 before we end the chapter, or this section, how do you find the slope of 4, negative 3, and 4, 2? If we're going to 4, negative 3, that means over 4 and down 3. We plot a point. 4, 2. Now at this point we should be thinking, oh, it's a vertical line. What do I know about vertical? Vertical lines are always undefined. You can check it, but at this point, undefined is our answer. And how would you get that? Again, remember, to get undefined, you would be dividing by 0. At this point, your notes, the vocab should be filled in, your rate, slope, or rate of change. You can use this next picture to put in your horizontal, vertical, positive, and negative slopes. So make sure you add this to that first page of notes, and hopefully this lesson will go well, and we'll be working on it in class.